Welcome to the Darwin Severe Weather Analysis for Friday, November 21st, 2025. We are analyzing this morning's 9 a.m. sounding to assess thunderstorm potential for today and tomorrow. This morning's sounding shows a tropical air mass with 742 joules per kilogram of mixed layer CAPE. On the skew-t diagram, the red line shows our temperature profile climbing to nearly 30 degrees at the surface, while the green dew point line indicates abundant moisture with 61 millimeters of precipitable water. The gap between these lines in the lower atmosphere tells us about the moisture available for storm development. Notice there's no blue shaded area, meaning there's no cap or lid holding things down. The pink shaded region between the blue dashed parcel path and the red temperature line represents our CAPE, the energy available for rising air parcels. With a lifting condensation level at 674 meters and modest wind shear of 11 meters per second through 6 kilometers, we have the ingredients for scattered storm development. As we heat into the afternoon with temperatures reaching 31 degrees, watch how the atmosphere transforms. The heated parcel analysis shows mixed layer CAPE increasing to 1053 joules per kilogram. The orange line on this enhanced diagram shows our heated parcel path, demonstrating how afternoon heating destabilizes the atmosphere. The lifting condensation level rises to 1078 meters as surface heating continues. With the supercell composite parameter climbing to 0.54 and no capping inversion to inhibit development, conditions become favorable for organized multicell storms with a possibility of weak supercells. The storm mode shifts from scattered activity to more organized structures. However, the significant tornado parameter remains low at 0.24, and with our relatively high LCL, tornado potential stays minimal. The main threats if storms develop would be heavy rainfall and perhaps some gusty winds, but severe weather remains unlikely today. Looking ahead to tomorrow afternoon, the forecast shows a dramatic change. The atmosphere stabilizes significantly with mixed layer CAPE dropping to just 102 joules per kilogram. This is well below the threshold needed for organized thunderstorm development. The shear remains modest at 13.3 meters per second, but without sufficient instability, the environment becomes subconvective. The supercell composite parameter falls to 0.04, and the significant tornado parameter drops to 0.01. Storm mode shifts to subconvective conditions with insufficient CAPE for sustained convection. Tomorrow looks much quieter with minimal thunderstorm potential as the atmosphere stabilizes and dries out slightly. The GraphCast machine learning model forecast for tomorrow morning confirms this stable trend. At 9 a.m. Saturday, the model predicts only 102 joules per kilogram of CAPE with a lifting condensation level at 684 meters. Wind shear through 6 kilometers holds near 13 meters per second, but without adequate instability, the ingredients for convection simply aren't there. The significant tornado parameter of 0.01 and supercell composite parameter of 0.04 both indicate subconvective conditions. The model shows minimal threat for any organized storm activity through tomorrow morning. The hodograph reveals our wind profile through the atmosphere. Starting near the center with light surface winds, we see the wind vector curving outward and changing direction with height, creating 74 meters squared per second squared of storm relative helicity in the lowest kilometer. The colorful spiral from the surface up to 12 kilometers shows mostly unidirectional shear, with winds veering from southeasterly near the surface to westerly aloft. The 0 to 6 kilometer bulk shear of 11.2 meters per second is moderate, but not particularly strong for supercell development. The bunker's right mover storm motion, marked with a red star, suggests storms would move toward the northeast if they develop. This wind profile supports multicellular organization but lacks the stronger curvature and speed shear typically associated with supercells. The atmospheric refractivity profile, or n-squared profile, shows us the stability structure of the atmosphere. Higher values on the horizontal axis indicate greater potential for radio wave ducting and anomalous propagation. We see two highlighted zones. The orange band near 1,000 meters indicates conditions favorable for elevated ducting, while the yellow band near 6,500 meters shows potential for superfraction. The smooth curve of the refractivity profile suggests a relatively well-mixed boundary layer without strong inversions. This profile is typical of tropical environments where moisture and temperature gradients create conditions that can bend radio waves beyond the normal horizon, affecting VHF and UHF communications. This analysis is for educational purposes only. Always consult the Bureau of Meteorology for official forecasts and warnings. Stay weather aware and be prepared to take action if conditions change. Thank you for watching the Darwin Severe Weather Analysis.